All right, welcome. Today, we are going to take a journey into the invisible world that makes up, well, everything. Your phone, the air you're breathing, that cup of coffee on your desk, all of it follows a hidden set of rules. So let's dive right in and figure out what they are. To get us started, I've got a question for you. I want you to think about the biggest thing you can possibly imagine, maybe a giant star billions of miles away. Now think about something super ordinary, like a glass of water. And finally, think about yourself. What's the one single thing that connects all of them? The answer? It's pretty wild. You are all made of the exact same stuff, matter. Everything you can possibly see, touch, or even breathe is made of this fundamental substance that has had scientists scratching their heads for centuries. So what even is this matter anyway? To us, it seems solid, right? Continuous. But as we're about to find out, its true nature is a whole lot weirder and honestly a lot less solid than you probably think.
Okay, so the official science-y definition is actually super simple. Matter is just anything that takes up space and has some weight to it, or mass. It's basically the stuff of the universe. From the clouds way up there to the floor under your feet, if it has volume and it has mass, it's matter.
Okay, now this is where things get really cool. For a long, long time, scientists argued about this huge question. Is matter one solid, continuous thing, or is it something totally different? And it turns out the answer is hiding in something you've probably done 1,000 times in your own kitchen. I mean, really think about it. You take a spoonful of salt, you stir it into a glass of water, and poof, it vanishes. But where did it actually go? Did it just blink out of existence? This little kitchen magic trick actually holds the key to one of the biggest secrets of the universe. And here's the big clue, the smoking gun, really. When you add that salt, the water level doesn't rise. This is the proof that matter isn't some solid block. Nope, it's made of unbelievably tiny particles with empty space between them. The salt didn't disappear, it just cleverly snuck into the gaps between the water particles. So that one simple observation, that all matter is made of these teeny tiny particles, is the key that unlocks everything that comes next. It points us to 3 fundamental rules that every single particle in the universe has to follow. And if you get these rules, you get how the world works. So, rule number 1, and we just saw this in action, particles have space between them. It's not just a theory, right? We just proved it. This is literally why you can mix sugar into your tea or why anything dissolves at all. It's all about finding those hidden empty spots. All right, rule number 2. These particles are never standing still. They're constantly buzzing around, wiggling, vibrating. Scientists call this kinetic energy. And here's the best part. The hotter things get, the faster the particles move. This is exactly why you can smell a sizzling barbecue from across the yard, but you have to stick your nose right in a bowl of cold food to smell anything. Those hot food particles are literally moving faster through the air and traveling right to your nose. And that brings us to rule number 3. Particles attract each other. There's this sort of invisible glue or stickiness that's constantly pulling them together. If this force didn't exist, well, everything in the universe would just fly apart. And the strength of this attraction, that's the final piece of the puzzle that explains why a rock feels so different from water. A great way to picture this is to think of particles like these I Do Mish Me dancers. In some things, like a solid, they're all linked up, holding on for dear life, super strong attraction. But in other things, they're just kind of loosely holding hands, ready to break away at any second. This difference in stickiness is what gives matter its form. So, let's put it all together. We've got these 3 rules, right? Particles have space, they're always moving, and they're always pulling on each other. It's this constant dance, this tug of war, that creates the 3 states of matter we see every single day. And this table just lays it all out perfectly. Look at solids. The attraction is super strong, so the particles are just locked in place, vibrating. That's why your desk keeps its shape. Now in a liquid, that attraction is a bit weaker. The particles have enough energy to kind of slide past each other, which is why water can flow into any shape. And then you get to gases. There's basically no attraction at all. The particles are just going crazy, flying all over the place to fill up whatever space they're in. That's also why you can compress a gas so easily. You're basically just squishing all that empty space together. So if we've got this constant battle going on between the energy-making particles want to fly apart and the attraction trying to hold them together, what does it take to change the winner? How do we get matter to switch from one state to another? Well, it's pretty simple, really. It all comes down to energy, usually in the form of heat. When you heat up a solid, you're giving those particles a major energy boost.
They start vibrating like crazy until, bam, they have enough power to break free from that rigid structure and melt into a liquid. Keep pumping in the heat, and they'll break away completely and escape as a gas.
But here's a weird thing. When you're melting ice, you can keep adding heat, but the temperature gets stuck at a chilly 0 degrees Celsius until every last bit of ice is gone. So, where is all that extra energy going? It's being used for one specific job: breaking the bonds between the water molecules. Scientists call this latent heat, or hidden heat. It's like secret energy that's changing the state of the matter without actually changing its temperature.
Okay, so we've got solid to liquid, liquid to gas. We know how that works. But what if matter could just skip the middleman? Can a solid just decide, you know what, I'm not doing the whole liquid thing, and turn straight into a gas?
Sublimation. Yup, it's a real thing. Sublimation is the name for that direct jump from a solid to a gas. And the most famous example is dry ice. It's just solid carbon dioxide, and it never ever melts into a puddle. It just turns straight into that spooky, cool-looking gas that you see at concerts and parties.
We've been talking about all this particle science, and it might feel a little abstract, but how does it actually show up in our lives? Well, it's the very reason your body has its own personal, built-in air conditioning system. The entire cooling mechanism of our bodies comes down to one powerful process: evaporation. And here's the surprising part. It's not the sweat itself that cools you down, but the process of it disappearing from your skin. So here's what's happening at the particle level. On the surface of the sweat on your skin, the fastest, most energetic water particles have enough oomph to break away and fly off as a gas. But to make that final leap, they need a little extra energy boost. And where do they get it? They steal that energy in the form of heat directly from your skin. As they escape, they take your body heat with them, leaving you feeling cooler. It's nature's perfect little cooling system. And that brings us to our final, kind of mind-bending thought. We've learned that everything, your hand, the screen you're watching this on, is made of tiny particles vibrating with huge amounts of empty space between them. So, if that's true, what are you really feeling when you touch something? Are you even truly touching it at all? Something to think about. Thanks for joining me.